Okay, so this is page 20, C7, using a Riemann or trapezoidal sum to find a missing value. So we're going to do a trapezoidal sum problem together. But first we'll do an interpretation exercise. Okay, so the height of the Susquehanna River can be modeled by a differentiable function h of t, where h of t is measured in feet and t is measured in hours since 8 p.m. on Sunday, December 3rd. Okay, and now we're going to do two interpretations. But guys, as soon as they say, as soon as you hear can be modeled by a differentiable function, when you hear that, immediately you can write or at least begin thinking about this derivative sequence. Okay, so I go like this. And so differentiable means that something has a derivative. So if h is differentiable, that means that h prime exists. It has a function that will give you the slope of the tangent line at any point. That's what it means to be differentiable. And then we're not going to really move into this territory that much just yet, but very often you will have a derivative that is also differentiable. So that would mean h is twice differentiable. In that case, you would have a third column for h double prime. So anyway, let's write in the units. So h is the height of the Susquehanna River, and its units, they told us, are feet. And as soon as you are moving over in the derivative sequence, you don't have feet anymore, but you have a rate. The feet are changing at a certain rate. So this would be feet per hour. And then if you move into the second derivative column, that is the rate of change of the rate of change. So that would be, so the thing that's changing is feet per hour. Per hour. And there's a way of writing that shorter, which I'll talk about another time. You may already know it. Okay, so whenever we're doing interpretations, you want to think of what where are we at in the derivative sequence. Okay, so part A. Let me just write this again with units. So h of 0 equals 3.6. So we're at the very beginning. We haven't even taken the derivative. We're right here. The units are feet. Okay. And guys, if you are interpreting something that's right here at the beginning of a derivative sequence, it pretty much is always going to go like this. At t equals something, at t equals blank, something equals a certain quantity. You don't have to write certain, but I like the way that sounds better. A certain quantity. At t equals 0, something equals a certain quantity. So if you just can think of it that way very generally and then try to fill in the pieces. So at t equals 0, something, what is this something? This is the river's height. Something is equal to a certain quantity. This certain quantity is 3.6 feet. Okay. Now I could make this even more detailed at the beginning. So at t equals 0, so that would mean at 8 p.m. Sunday, 12:03, the river's height is 3.6 feet, or the river is 3.6 feet high. That probably sounds even better, even more like how people talk. So I'll say it like that. All right, so at 8 p.m. Sunday, 12:03, the river is 3.6 feet high. Okay? Or you could have said it, exactly like this. Okay, now for B. So now we are interpreting h prime of 24, and that equals 0.039. Let's just, rewrite it with units first. So h prime is this here. So the units are going to be feet per hour. Okay, and if you're interpreting the first derivative, it'll go something like this. So at t equals, and this is IROC, this is the same thing as IROC. At t equals blank, something is changing at an instantaneous rate of blank. Okay, so we're interpreting IROC, by the way. And if you feel like it'd be helpful to write that in your notes, you definitely should. So h prime of 24. So at t equals 24, something is changing. So the river's height is, okay, now the changing part, guys, you have to figure out if it's increasing or decreasing. The river's height is, since we have a positive rate of change indicates an increase. So the river's height is increasing at an instantaneous rate of 0.039 feet per hour. Okay. Now, by the way, guys, saying instantaneous, this is optional. If you just say rate, they will assume instantaneous. It will be understood instantaneous. Average is not optional to write, but instantaneous is. Okay, and then I can make this more detailed at the beginning. At t equals 24 hours, so that would be 8 p.m. Monday. Monday 12/4. Okay, so I'll write it at 8 p.m. for the height of the river is increasing at a rate of 0.039 feet per hour. The height of the river is increasing at a rate of... Okay, beautiful. All right, now for this example. So selected values of the continuous function f of x are shown in the table below. Given that the trapezoidal sum approximation for the integral from 0 to 9 of f of x using 3 subintervals is 82.5, what is the value of k? All right, so guys, we have to do a trapezoidal sum. So we've got this graph, and the area underneath it, we are going to approximate by drawing trapezoids using the values that we know. And this is a continuous function, so there's values like, between. Okay, so, alrighty, let's just show the first trapezoid so you could see it. First trapezoid would look like this. So it'd be from 0 to 2. All right, 0, let's say that 2 is there. And then the graph has y values. At 0, we're at 16, and at 2, at 14. Okay, so the bases of the trapezoid are going to be, all right, that's going to be one of the bases. And then that's going to be the other base. Okay. And then you connect the bases like that. Okay, and then we're going to get the area of that. So that is the trapezoid, but it is on its side. So this is the height. So this would be h1. All right, so that would be height 1. And then these would be like base 1 and base 2. But anyway, we have to average them, is the thing. So the area of just this one is 16 plus 14 divided by 2 times the height, which is 2. And this thing here, guys, this is the average of the bases. So that is 15. Yeah, so that's just 15. All right, so anyway, there's like a visual for it. But the way we could just do this in the table is like this. So from 0 to 2, that is height 1. From 2 to 6 is height 2. From 6 to 9 is height 3. And then what we've got to do is, so those are going to be the heights. So those are like 2. And then we're going to have to multiply that by each height by the average of the bases that it corresponds to. So here we're going to be averaging them. So 16 plus 14 over 2, that's 15. 14 plus k over 2. We don't know what k is, so we can't get a number for it. And then k plus 7 over 2. Okay, so the trapezoidal sum goes like this. It goes 15, right, that's the average of the bases, times 2, that's the height, plus 14 plus k over 2 times, this time the height is 4, plus k plus 7 over 2, and this time the height is 3. Okay, so that's the trapezoidal sum with 3 subintervals, and they told us it is equal to 82.5. So we're going to have to like distribute and stuff over here and solve for k. So that's going to happen. All right, so we've got 30, 28 plus 2k. Plus, okay, I'm distributing the 3. So this is 3 halves k plus 21 halves. Okay, guys, definitely go ahead of me, if you've got this. All right. Yep, so now we're just doing the math. So this is 58 plus, okay, so 2 is 4 halves. Yeah, try to do it definitely without a calculator. All right, so 2 is 4 halves. So 4 halves plus 3 halves is 7 halves. Okay, so 7 halves k plus 10.5. Okay. 7 halves k plus 58. Okay, 72 is 14. Okay, and then divide both sides by 7 halves. All right, guys, the answer is 4. Okay, so k equals 4. If k were 4, then the trapezoidal sum would be 82.5.